Welcome to the deep dive. The AI landscape, it just shifts at this incredible pace. And while we're constantly amazed by new models, new capabilities, the real challenge for engineers, it often just boils down to this. How do you actually turn those complex AI models into reliable, practical applications, things that actually perform in the real world? Building an agent, well, that's one thing, but making sure it's robust, testable, scalable for actual deployment, that's the real hurdle.
Exactly. Yeah, and that's really what we're here to unpack today. We're diving into some pretty crucial tools that are helping AI engineers not just build, but maybe more importantly, trace, evaluate, and really harden their AI apps, their LLM applications. And we'll also look at how these AI agents can interact with the web in a way that's, well, far more human-like, more resilient. And then, yeah, we're going to showcase this fantastic array of modular component-based projects. They really demonstrate what's truly possible when you approach AI development with precision.
Okay, and our source for this deep dive, it comes from Avi Chawla's article, 9 MCP Projects for AI Engineers. This was in the Daily Dose of Data Science newsletter, published June 10th, 2025. What's really exciting about this source, I think, is its promise. It says, explain with visuals and open source code, which, perfectly aligns with the practical, hands-on insights we want to uncover. And for anyone wondering, MCP, what's that? In this context, it stands for modular or multi-component projects. It's a really smart, practical way to build AI, breaking down complex systems into these manageable, kind of reusable parts.
Right. So our mission for you today is pretty clear. By the end of this deep dive, you'll not only have a much clearer understanding of these critical tools, the ones essential for robust AI app development, but you'll also get a concrete view of some diverse, pretty exciting AI projects, things you might not have even realized were within reach for developers right now. Think of it as maybe a shortcut to getting up to speed on cutting edge of practical AI engineering.
Okay, let's unpack this first key area then. Tracing and evaluating AI LLM applications. As you know, testing AI at scale, especially on real-world scenarios, that's incredibly challenging. It's often where, the rubber meets the road, the difference between just a prototype and a system ready for production. And the source introduces LangWatch as a powerful solution directly addressing this problem.
Yeah, and what's fascinating here is how LangWatch integrates into your existing workflows. It lets you add evaluation tracking to, well, pretty much any LLM workflow you have. You can even keep using tools you're already familiar with, like Pandas, for the data analysis part. The process itself is actually quite straightforward. You initialize an eval, then you decorate your LLM workflow logic method. Think of it like adding the small non-intrusive tag to your code that basically tells LangWatch, hey, this bit here, this is what I want you to evaluate for performance, accuracy, that sort of thing. And then you just log the evaluation. It's designed to be seamless, not requiring a total rewrite.
Right. Seamless is key. And here's where it gets really interesting, I think, for building reliable AI apps. LangWatch integrates directly into CI/CD workflows. Your continuous integration, continuous deployment pipelines. Now, this isn't just about automation. It feels like a fundamental shift towards maybe AI ops. Operationalizing AI quality. It means every time you update your model, it can be automatically checked, evaluated before deployment. That proactively builds in trust and hopefully significantly reduces those insidious silent failures that can plague AI systems in production. It really seems to address a major headache. But what's the biggest hurdle for an engineer trying to integrate it? Is it the setup or maybe just dealing with the sheer volume of evaluations?
That's a great question. Often, the initial setup is surprisingly straightforward, actually. The documentation seems pretty good. The real deep dive for an engineer, I think, comes into figuring out which evaluation metrics truly matter for their specific LLM application.
Yeah.
You know, that's where the real engineering insight kicks in, defining what good looks like for your use case. The good news is its GitHub repo is active, seems to have strong community support, which is always a good sign.
Yeah, definitely. Okay, speaking of practical AI applications, another massive challenge for engineers is enabling AI agents to interact with the real world, particularly the web, right? Doing it robustly, adaptably, trying to automate web browsing with, say, traditional tools like Playwright or Selenium. It can be incredibly brittle,
Oh.
always breaking with minor web page changes. That's where tools like Stagehand come into the picture.
Precisely. Stagehand's core function, fundamentally, is allowing AI agents to independently control a web browser. But what's crucial here is the level of control it offers. It's kind of a Goldilocks level, you could say. It recognizes that full, unpredictable AI autonomy isn't always ideal, and those brittle scripts, they always fail eventually. So Stagehand bridges that gap. It gives AI agents enough flexibility to adapt, to interact robustly, without engineers completely losing oversight. For instance, It integrates its MCP server with Claude Desktop. That offers a potentially much more reliable alternative to something like OpenAI Operator for certain kinds of tasks.
Okay, so it's not a complete black box, and it's not just a script that'll break tomorrow. Finding that perfect sweet spot, sounds like a game changer for practical deployment. But even with that advanced approach, are there scenarios where it still falls short? Maybe dealing with highly dynamic JavaScript-heavy sites?
Yeah.
Or really complex multi-step workflows needing subtle human-like decisions?
That's a perceptive question. Yeah. While Stagehand is remarkably robust, there are always going to be edge cases, right? Highly complex interactions can still pose challenges. However, its unique flexibility, the fact that you can always decide how much control to give the AI, that's key. You can fine-tune it. And the fact that it's 100% open source and, get this, boasts over 12,000 stars on GitHub.
Wow, 12K plus salt.
Yeah, that speaks volumes about its community adoption.
Yeah.
Its robustness has likely been tested in diverse scenarios. It's clearly a tool delivering real value.
Okay, so we've discussed these crucial tools, LangWatch for evaluation, Stagehand for interaction. They underpin robust AI development. But how do these ideas, modularity, reliability, how do they translate into actual tangible applications? This is where the rubber really meets the road. Let's dive into some of these specific MCP projects for AI engineers from the source. These are practical, hands-on projects you could actually build. Project number one, for instance, it focuses on building a 100% local MCP client. This client is essentially a fundamental component within an AI app like Cursor, maybe, that connects to external tools. It's like the foundational building block for everything else.
That's right. And many of these projects, they really highlight the power of advanced data retrieval and analysis, which, as we know, is critical for making AI agents truly intelligent. So, for instance, Project #2. It teaches you to build an MCP-powered Agentic RAG, that's retrieval augmented generation. It's an approach where your AI intelligently searches a separate knowledge base, often a vector database, pulling in relevant info before it generates a response. Makes answers way more informed, more accurate.
Contextual.
Exactly. Then there's Project #7, an MCP-powered RE, but designed specifically for complex documents. Think about how challenging it is for AI to parse info from PDFs with tables, charts, images, complex layouts.
Oh yeah, nightmare.
Right. This project tackles that common hurdle head-on.
So the theme here is getting data intelligently, not just text, but from complex sources using these modular components. That's a significant leap beyond just basic text interactions.
Absolutely. And it extends into specialized domains, too. Project #3, the MCP-powered financial analyst. It describes an AI agent that can fetch, analyze, generate insights on stock market trends, right, from platforms like Cursor or Claude Desktop. Imagine the speed, the breadth of analysis that enables.
Real-time insights almost.
Potentially.
Yeah.
And for really broad data access, Project #5 is this unified MCP server. Its scope is impressive. It lets you query and chat with over 200 data sources using natural language.
200, wow.
Yeah, 200 plus, all through a unified interface. It uses MindsDB and Cursor IDE. MindsDB is like this connector database, links to almost everything. And Cursor IDE, the AI native code editor, it's about making all these disparate data sources instantly accessible, conversational for your AI. And finally, in this group, Project #9, the MCP-powered Deep Researcher. It offers a 100% local alternative to features like ChatGPT's Deep Research. So getting really detailed insights on pretty much any topic, but without sending your data out to external services.
Yeah.
Which is huge for privacy or sensitive data.
That's an incredible breadth of capability just for data handling and research. Amazing. But it's not just about data analysis, right? These projects also get into how agents interact and function in different ways, different modalities. Project #4, for example, describes an MCP-powered voice agent. It can query a database and, again, intelligently fall back to web search if needed. So bringing AI out of the text box into voice interactions.
Making it more accessible.
Exactly. And then there's Project #6, which tackles a really common developer pain point, I think. MCP-powered shared memory for Claude Desktop and Cursor. You know how developers often use these tools independently? They lose context between sessions or apps.
Oh yeah, happens all the time.
This project solves that. It adds a common memory layer, allowing cross-operation without losing that crucial context. It's like giving your AI a persistent memory across its tasks.
And finally, there's a project focused on data generation. Often overlooked, but incredibly important. Project #8. It's an MCP-powered synthetic data generator. Teaches you how to build an MCP server that can generate, well, pretty much any type of synthetic data set.
Yeah.
It uses Cursor as the MCP host and leverages SDV, that's the synthetic data vault. And this is crucial because SDD goes beyond just randomizing data. It uses advanced statistical models to make sure the patterns and relationships in the synthetic data actually mirror real-world data.
Ah, so it's realistic synthetic data.
Exactly. Vital for training robust models without exposing sensitive or private information.
Okay, so what does this all mean for you, the listener, listening in right now? These 9 projects, I mean, from advanced financial analysis to deep research, voice agents, even sophisticated synthetic data generation, they really demonstrate this incredible range of practical applications you can build using this modular approach. It's those aha moments, right? Where you see how these theoretical AI concepts actually translate into tangible, useful tools, tools that make a real difference in building reliable, real-world AI.
Yeah, what's truly fascinating here, I think, is that these projects, taken together, they really highlight how AI engineers can build sophisticated specialized applications. By strategically integrating these modular components, you get a level of precision, a level of control that's absolutely crucial for reliable, real-world deployment. It's moving beyond simple demos to truly operational AI systems.
So we've covered a lot today. We explored how essential tools like LangWatch provide that crucial infrastructure for evaluating, for ensuring the quality of AI apps, and how Stagehand enables more human-like, robust interactions for AI agents on the web, more reliable browsing. Then we dove deep into those 9 distinct MCP projects, showcasing the incredible breadth, the practical possibilities in modern AI engineering, all built on that modular, component-based approach.
Right. And maybe final thought to leave you with. If knowledge is most valuable when it's understood and applied, think about how these modular component-based AI projects, each one powerful on its own, could be combined or adapted to create even more complex, more adaptive, more intelligent systems, systems that might solve problems we currently think are intractable. What new possibilities emerge when you start thinking about these focused projects, not just as endpoints, but as fundamental building blocks for whatever the next generation of AI innovation looks like?